We want to solve problem in trigonometry, which is on page 128, exercise 4, number 2, which is problem in 3D. Right, here is the question. Let's zoom it. The question says, in the diagram, A, B, C are points in the same horizontal plane. CD is a vertical tower. The angle of elevation from A to C is X, and DBA, angle DBA equals to Y, AD equals to DB, and AC equals to K. So looking at this diagram, which is the same diagram, so we have DC, which is a vertical tower, and then we have our horizontal plane CAB, and then we have our inclined plane, which is DAB, and then we have our right angled, or which is vertical plane, ACD, BCD. So these two triangles are right angled triangle, triangle ACD and triangle BCD, because CD is perpendicular to the horizontal plane ACB. Right, so we're also told that angle DBA is Y. So in this question, we must be very, very careful not to say angle CBA plus angle plus angle CBD equals to Y. Angle Y is the angle for triangle DBA. So these are not the same triangles, so therefore the angles are not, when you add the two angles, they don't give you angle Y. Right. So we want to prove that side AB equals to side AB equals to 2k cos Y over cos X. All right. If we look at the diagram, before we can answer the question, let's look at the steps that we should follow in order for us to be able to answer this question. Right. So these are the steps that you must follow for us to answer this type of a question, a 3D or 2D problems. Use your geometry knowledge and fill in as many angles as you can, especially the 90 degrees angle, which we already did. Start with the triangles which has a given length. Use the cosine rule when two sides and the included angle are given, or three sides to find an angle, two sides and included angle. So this is the two side and the included angle. Right, use the sine rule when a side and the opposite it are given and one other angle or a side. So if this is a triangle, so we are given this angle, we must also be given a side opposite the angle, then at least one other side or angle, so that we can find the other side or the other angle. Find a side which links two triangles. Use this side to solve sides or angles in the other triangles. Repeat the process until you have found what is required. Use double and compound angles identities to prove or arrive at the final answer for the algebraic proof. Right. So we want to prove that AB equals to 2k cos y over cos x. From the given information, the first step says we must use geometry to fill in as many angles as we can. Right. So we're told that angle DBA equals to y. So this one is given, and we were told that DA equals to DB. We were also told that DAC equals to K, which is the side. Right. So using geometry, since DA equals to DB, therefore angle DAB equals to angle DBA. Therefore this angle is also equals to y. Reason being, angles opposite equal sides. Therefore, using the sum of angles of a triangle, we can find angle D. Angle D will be equals to 180 degrees minus 2y. Sum of angles of a triangle, because angle ADAB equals to y and ABD equals to y. Therefore, angle D equals to 180 minus 2y. Right. So the next step says start with the triangle which has a given length. So we are looking for AB. So this length, we are given length AC. So if we go to the next step, which says start with the triangle which has a given length. So the given length is K. So we can start by saying, we can find AD in terms of K and X. Because if you check here our proof, we must write it in terms of K and X. So we must find AD in terms of K and X. So if you check, this is 90 degrees, therefore AD is our hypotenuse and K will be our adjacent if we use angle X. Therefore, cos X equals to K over AD, which is therefore AD equals to K over cos X. And therefore we can also write, alright, there's no need. K equals to, AD equals to K over cos X. Therefore, to find AB, we check which rule we can use. Can we use the cosine rule or sine rule? To use the cosine rule, we must have, when we are looking for a side, we must have two sides and the included angle. So let's prove this one using the cosine rule, because we also know that AD equals to DB. Therefore, DB equals to K over cos X. And we also know the angle opposite AB. Using cosine rule, we know that AB squared equals to AD squared plus DB squared minus 2AD times DB cos D. This is from triangle DAB. Right. Then we substitute. We know that AD is K over cos X squared plus K over cos X squared minus 2 into K over cos X times K over cos X times cos. What is D? D is 180 minus 2y times 180 minus 2y. Right. Then we continue working this out. K over cos X squared plus K over cos squared, plus K over cos X squared gives us 2K over cos X all squared. Right. Minus K over cos X times K over cos X, which is 2 times K over cos X squared times cos 180 minus second quadrant. In the second quadrant, cos is negative. Then we have negative cos 2y. So cos 2y, then we must start thinking of double angles. Right. And negative times negative is positive. Then we'll have 2 times K over cos X all squared minus plus negative times negative 2 times K over cos X times cos 2y. Right, we can take out 2 times K over cos 2y. We can't add this 2 because these are not like terms. Since here we multiply, we take out, right, we take 2 into K over cos X squared out as a common factor. 2 into K over cos X squared out. Then we are left with 4 1 plus cos 2y. Then we continue 2 k over cos x squared into 1 plus. Then we change our cos 2y into 2 cos y minus 1 cos squared y minus 1. And then we have 1 minus 1. Then we left with 2k over cos squared times 2 cos squared y. Right. Then we're gonna have k squared or cos x. Then we have cos squared, k squared over cos squared x. We multiply 2 and 2. We'll have 4 k squared 2 times 2 over cos squared x cos squared y. And then we introduce square root. Then we'll have 2k cos y over cos x. Right. So this is the final answer, because we wanted to prove that AB equals to 2k cos y over cos x. We can also answer this question. We can also do this question, answer the same question using our sine rule. Right, let's do the same question, prove it using our sine rule. Right, using sine rule, we already know what is AD, and then if we look at the triangle, if we look at the triangle using the sine rule, we are looking for AB. We know D, and then we know AD, and we also know B. Therefore, using the sine rule, we have a side and opposite angle, and then we have angle and unknown side. Therefore, using the sine rule. Right, we can also prove this. Prove that AB equals to 2k cos y over cos x using sine rule. Using sine rule, we know we are looking for AB and we know D, and then we have AD and then we know B. So we'll have AB over sine 180 degrees minus 2y equals to AD. What is AD? AD is k over cos x over sine y. Then we cross multiply. AB equals to k cos x. Then sine 180 minus, it's going to be sine 2y times sine 2y, it's k over cos x all over sine y, which is equals to k over cos x times, then we change this into double angles. This is a double angle, so we change it into 2 sine y times cos y all over sine y. And then your sine y cancels sine y. Then we are left with 2k cos y over cos x. So in this question, we were able to use both sine and cosine rule. Right. Thank you very much.